Hello everyone, welcome to college algebra courses. Today I'm gonna cover the first three sections of our course, section 1.5, 1.6, and section 2.1. So let me start with section 1.5. It is about solving inequalities. Solving inequalities. First, let me start this section by recalling the interval notations. Interval notations. Alright, so basically we use interval notation to express an inequalities. But we're going to start with the first type of interval notation called the open interval. Open intervals. Okay. The open interval is denoted by parentheses. Alright. For example, if you have something like 1 less than x less than 4. First of all, please notice that in our college algebra class, we are talking about the real numbers. Means what? You have the whole number like 1, 2, 3. You have positive, negative numbers. You also have fractions. You have rational, irrational numbers, square root of 2, all kind of thing. Pi, not just the whole numbers. Okay. So whenever you guys see something like 1 less than x less than 4, and you can think of what? Yeah, 2 is good in here, right? 2 is if x equal to 2, of course 1 is less than 2 and 2 is less than 4 also. You can think of x equal to 3. But not just 2 and 3. You may have x equal to say 3.5. How about pi? Because pi is 3.14159, so all real numbers in here, okay? That's first thing. Second, this inequality is a strict inequality. No equal sign. So what? The value of x right here is going to be strictly bigger than 1. So 1 is not okay for x. But if x equals to say 1.001, that'd be okay. And similarly, x is going to be strictly less than 4. X is going to be like 3.9, 3.9999. It's okay, but not 4. Okay? And whenever you guys see this and an inequality like this, you're going to use the open interval notation to express. So x is in the interval of what? 1, 4. And this means that we are talking about all the real values of x are strictly bigger than 1 and strictly less than 4. Okay? Okay? And we also have another way to express the inequality using something called the number lines. Okay? This is a number line. Then 0 here is the origin. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. To indicate that we are looking at all the value of x between 1 and 4, we're going to highlight the line segment from 1 to 4. Okay? And now we're going to talk about the endpoints, 1 and 4. If you are excluding, you're not including 1 and 4, some books use the open dot like this. Okay? And you look at this and say, oh, I'm talking about all the numbers. What? Bigger than 1 and less than 4, not including 1 and 4. Many other books, they don't want to use the open dot, so they use parentheses. They go this way. And this means exactly the same thing because it's parentheses right there. Okay? This is the first thing that we learned today, the open interval. I bet you guys know this from the previous class. It's just a recall, but it's helpful to start our college algebra. Second, we're going to talk about closed interval. All right. And closed interval is denoted using square bracket. Is that too light? Let me rewrite it, make it darker. Older. There you go, AB. Okay. The idea is very similar to open interval, but this time our inequality is going to include the equal sign. So if you have something like, say, -1 less than or equal to x and less than or equal to 3, for example. Can I see the difference? This one's what? No equal sign. This one less than or equal to. And that means what? We are including the endpoints, -1 and -3, into our solution. Means what? X could be -1, x could be 3. Okay, that'd be okay. And of course, for this example, square bracket -1, comma 3. There's one thing that I need to mention about the interval notation. You see what? The rule is what? Either parenthesis or bracket. But when you write a number, it's always what? Smaller number come first, and then comma, and then the bigger number. Okay? You don't write parenthesis 4, comma 1. This would make no sense in terms of interval notation. Okay? Okay? It have different meanings, different contexts. But for interval notation, small number comes first, and then parenthesis, and then, I'm sorry, comma, and then bigger number, and then either close to parenthesis or square bracket. And similarly, you can express that interval on the number line 0, 1, 2, 3, 4, -1, -2. Now for square bracket, you also highlight the light segment from -1 to 3, right? And this time, instead of using open dot, you guys got to use the solid dot. Or instead of use parenthesis, you guys got to use square bracket. Okay. Either way, you guys do the homework. You see. Okay. And then, of course, the third type is what? It's a mix between the open and closed interval. You can open on one side, close on the other side. But before getting there, let me introduce to you guys, or recall the notation that you guys, I bet many of you know before. The infinity notation. Infinity. Infinity is denoted by like horizontal 8. Okay? So this is called what? Positive infinity. And for now, it's not really a number. It means, an abstract concept means what? Something that really, really positive, really, really big. And similarly, if you put a minus sign in front, you got something called negative infinity. And that means what? It's really small. And of course, on a number line, positive infinities are something like very far away from to the right hand side. And negative infinity is something that's very far away to the left hand side. Okay? So positive infinity is something that's bigger than any specific number that you can think of. And negative infinity is something that is smaller than any negative number you can think of. Okay? Now, I think it's time to talk about the mix of those two intervals. So, say half open, or some book called half closed interval. Number 3. Half open interval. Half open intervals. Okay. And you guys are going to use this notation to represent such a thing like this. Let me write the notation first. You can have this 2 ways. Okay. Parenthesis A, comma B, and then square bracket. Or square bracket A, comma B, and then parenthesis. You see? Parenthesis means open, right? Bracket means close. We learned before. But this is what? Open on the left and close on the right, or close on the left and then open on the right. Examples, say you have something like 0 less than x, less than 4, less than or equal to 4. Okay? And in here, what we are talking about, all real number x got to be strictly greater than 0, means it's got to be positive and less than or equal to 4. So x cannot be equal to 0, but x can be equal to 4. Okay, so this is what? Parentheses 0, comma 4, and then square bracket. Okay. Anything. 0 is not okay in this interval, but 4 is okay. And if I have something like -3 less than or equal to x, less than 0, for example. And now what? Equal sign got on the first inequality and then not on the second inequality. So this is what? Square bracket -3, comma 0, and then parenthesis. Alright, and of course you can draw line segment on the number line and highlight. So what? It's going to be open dot on this side and then close dot on the other side, or what? Parenthesis and then square bracket. And similarly, close dot on this side and open dot on the other side. Okay. Now you may have just a kind of inequality like this. Let me draw it right here. Say x is greater than 2. Okay? Means what? 2 is less than x, right? This is another way of writing 2 is less than x. So what? We are talking about all values of x will be strictly bigger than 2. If this is my number line, 0 right here, 1 right here, 2 right here, x is greater than 2 means what? X is bigger than 2. Let me use red color. All the way from 2 to infinity, and not including 2. So they can use what? Open dot right here or parenthesis. Okay, either way. And how do you represent that kind of ray, right? Using the interval notation, and we got to use that infinity notation right here. Write this. Open dot, start with smaller numbers, so parenthesis, 2, comma, infinity. And that means what? I'm talking about a number that starts from 2 and bigger, but I'm not including 2, so I'm using the parenthesis. Similarly, if I have something like f is less than or equal to -1. Now what? We are looking for all values of x, it's got to be smaller than or equal to -1. And if we don't see it yet, one more time, number line is always a big helper. So 1 here, 2 here, -1 here, -2 here, -3 here. And what values of x are you talking about in this interval, in this inequality? Anything that's from -infinity to -1, right? -1 or less, smaller than -1. So we got to highlight this line segment right here, all the way to -1. Are we including -1? Yes. So we're going to use a solid dot. Okay. So how do we use interval notation to represent this? Again, the rule is a smaller first and then bigger number, right? And parenthesis. Alright. All the way to the left is -infinity, and then comma, -1. But this time we have to use square bracket to end because we are including -1 in our interval. Okay? So you guys see one thing in here. Whenever we have infinity or -infinity, we will always use parentheses. That's good for now, okay? And then later on, you'll learn more about real numbers, and if we define infinity as a number later on, way later, then we may use square bracket for infinity. For now, you see what? Always use what? Parentheses for infinity. I mean both negative and positive infinities. Okay? And you should be right. So far, so good. So we're done with the first item on interval notation. Now we're gonna talk about some properties of inequality before we can start solving. Number 2. Properties of inequalities. Properties of inequality. Okay. The very first property that you guys learn in real number is this. Whenever you square up a number, I don't know what number is. Let's call it A. An A square. Whenever you have a real number, doesn't matter if it's positive or negative, if you square it up, you will always have something non-negative. You pay attention to the way I say it. I say non-negative means what? Could be positive, could be equal to 0. Okay? Positive means strictly bigger than 0. Negative means strictly smaller than 0. So non-negative means what? Positive or equal to 0. Okay? Any real number, square up, always greater than or equal to 0. Okay? For sure. And of course, A squared gonna be strictly positive if and only if A is non-zero. And this means what? The only case that you have a squared equal to 0 is a is equal to 0 itself. Okay? If a is positive or negative, say negative 2 squared is 4. Positive 2, positive squared is 4. So positive. Only number square up equal to 0 is 0 itself. Okay? It's very important, right? It's kind of obvious. The first property is this. Second property, if you have an inequality and you add a number on both sides of inequality, regardless of the sign of that number, could be a positive number, could be a negative number. Whenever you guys add a number to an inequality, you have the same inequality. So this is saying this. If A is bigger than B, then A plus C, not D, right? C. It's bigger than B plus C. So see what we're doing in here? We're adding the same amount C on both sides. And we already have A is greater than B. Then you add C on both sides, and the sum on the left-hand side is bigger than the sum on the right-hand side. Okay? It looks trivial, but it's actually very helpful. Example. Solve for x. Okay, and this is what you have. X minus 5 is bigger than negative 2. Okay, and you see that you have an inequality, right? Something on the left is bigger than something on the right. Now you want to solve this, kind of adding the 5 on both sides, right? Cancel out the 5, right? So add 5 on both sides, add 5 on both sides. And this probably say what? Whenever you add the same amount on both sides, the inequalities stay the same. So what? X is greater than negative 2 plus 5 is 3. Okay? So you have the answer. So it means what? All real number x is greater than 3 will satisfy this inequality. And if you want to express the answer in the interval notation, it's going to be, for instance, 3. Okay. And if it works for this course, it's worked for less than or greater than equal to, less than equal to, it's the same thing. All right. That's the second property. Now let's talk about what if we multiply both sides by the same quantity C. And now it's different, okay? Be very careful. It depends on the sign of C. Alright. Property 3. Okay. So how about 3A then? If A is greater than B and the number C is positive. Okay. Let me make it clear. Positive, right? So you have an inequality, the left-hand side is bigger than the right-hand side, and then you have a number C that's positive. Okay? Positive. Not 0. Positive. What if I multiply both sides by C? Then A times C compared to B times C. You are multiplying both sides by a positive number, the inequalities stay the same. Okay? Now if you multiply both sides by a negative number, and guess what happened? You're going to flip the inequality. So let me write here. If A is greater than B and C is negative, then A times C will be, let me emphasize by using red color, less than B times C. And of course it's going to work the same way if you have other inequalities like greater than equal to, less than equal to. It's going to work the same way. Okay, so let me give you another example. Again, solve for x. You can have something like, how about x minus 2 over negative 3 greater than or equal to negative 1. Solve for x, right? So first of all, we try to simplify the fraction on the left-hand side. And it's kind of natural, kind of makes sense to multiply both sides by negative 3. So if I multiply the left hand side by negative 3, I got x minus 2 over negative 3, and then I times negative 3. And then on the right hand side, I do the same thing, negative 1 times negative 3. Now we have to apply the property right here. We multiply both sides by a negative number. What do? We're going to flip that inequality. So let me flip this. Okay. Let's simplify. I have a negative 3 on the denominator, that's on the bottom, and then negative 3 on the numerator, let's go on the top. Cancel out. So the left hand side will be x minus 2. The right hand side is what? Negative 1 times negative 3 is positive, double negative, make it positive, and now the inequality is less than or equal to. Now, things much simpler, alright? We're going to add 2 on both sides. Add 2 on both sides. And which we learned before, property number 2. Doesn't matter what, whenever you add or subtract a number, the inequality stays the same. So x is less than or equal to 5. Okay? So 5 or smaller, including 5. And of course, if you want to represent your answer as an interval notation, it's going to be parentheses negative infinity all the way to 5. And then square bracket. Okay? Now, let me try to give you one more example before I move on to section 1.6. Let's make this example a little bit more complicated. Okay, I'm going to have a combination of inequalities. Still solve for x, okay? And this is what we have. How about this? Negative 1 less than 2x plus 3, say, over negative 3, and then less than or equal to 5. I just make up, okay? Now you see that it's not one inequality anymore. In this example, you guys have 2 inequalities. The strict inequality on the left, so, and then the less than equal inequality on the right, okay? So what? We have actually 2 inequalities. Negative 1 less than 2x plus 3 over negative 3. And then 2x plus 3 over negative 3 less than equal to 5. And I claim that we can solve the 2 inequalities at once. And the first thing we're going to do is we're going to multiply all the sides by negative 3 to get rid of that denominator. And what we learned before, whenever you multiply by a negative number, you're going to flip the inequalities. Okay? So negative 1, I'm going to times negative 3. And then in the middle one, I got what? 2x plus 3 over negative 3. And I got to times negative 3. And then on the right hand side, I got 5 times negative 3. Okay, so I'm multiplying a negative number on all the sides. And according to what we learned before, we have to flip. Less than now becomes greater than. Less than equal to now becomes greater than equal to. Okay, and this what we have. Negative 1 times negative 3 is 3. Get rid of the denominator. It's going to be greater than 2x plus 3. And then on the right hand side is greater than or equal to negative 15. Okay, now things simple. Next step, add negative 3 on all the sides. Another way of saying add negative 3 is subtract the 3. Alright? And with this problem of adding or subtracting a number, the inequality stay the same. So let's subtract the 3, subtract the 3, subtract the 3. I got 0. Right? 3 minus 3 is 0. Greater than 2x. And then greater than or equal to negative 15 minus 3 is negative 18. And now what? Divide all the sides by 2, right? Divide by 2, divide by 2, divide by 2. See, multiply or divide, we have to look at the sign. 2 is a positive number. So whenever you divide by 2, by a positive number in general, the inequality won't change. So 0 divided by 2 is still 0. It's greater than x, greater than or equal to negative 9, right? So x is a number somewhere between negative 9 to 0. Let's say from small number to big number, okay? Including negative 9, not including 0. And if you want to use interval notation to represent your solution, we're going to start with smaller number and then end up with a bigger number, including -9. So square bracket, excluding 0, use parenthesis. And this is half open interval. Okay. So here are a couple of examples. Hopefully you guys see the way we're tackling the inequality problems using some basic properties of real numbers. Okay. Multiply by positive and negative number, add and subtract positive and negative number, and the interval notation is always a big help for representing our solution. Okay. Let's end section 1.5 right here. Let me move on to the next section, 1.6. I'll be talking about the absolute values. Okay. Section 1.6. Oh, I used a red color. Change to black. 1.6. Absolute values. All right. First, let me give you a definition of what it means by absolute value. Number one definition. The absolute value of a number x is the distance, emphasize the word distance, from x to the origin 0 on the number line. Number line. I missed a B right here. Number line. Okay. And the absolute value notation will be denoted by this. Denote by this. Okay. So what am I talking about here? Say you guys have a number line. All right. The origin is right here. 0 is right here. Origin is right here. 1, 2, 3, 4, 5. -1, -2, -3, -4. Anyway. Okay. So you got a number x. X is somewhere right here. X. Okay? Absolute value of x means what? How far is it from the origin? That's distance right here. Distance is the key. Okay? Similarly, x is in this side, so x is right here. Okay? Then absolute value of x is that much. Okay? Absolute value of x. The distance from that number to the origin. Okay. After having a definition, I'm going to talk about some basic properties of absolute value. Some properties. Since the absolute values means a distance, and you know that distance will never be negative. So the first property says this: absolute value of a, any number. Okay, I don't know what it is because a is always greater than or equal to 0. Because distance will never be negative, right? So this from origin to any number is going to be a positive number. So you got what? Absolute value of 3 is equal to 3 because the distance from 3 is right here, 3 to origin is 3. Absolute value of -2 to the origin is equal to 2. Okay? What about absolute value of 0? It's going to be equal to 0 because the distance from 0 to itself is 0. And recall what we just learned a couple of minutes ago about the inequality for square up a positive number. We have similar property in here. Okay. The only number that got distance equal to 0 is the number 0 is